So, a volcano is an opening in the earth that erupts gases, ash, and lava. We've got different kinds of volcanoes, different shapes of volcanoes. Magma is when the molten material is below ground. You already know that. We've talked about that before. Once it becomes above ground, now we call that molten material lava. And when we say molten, that means hot, right? Liquid. So we're talking about liquid rock here at this point. And the convection currents we talked about yesterday in the lava lamp, now you're going to see how they work in the earth and how this makes this happen. The magma from the mantle is going to get pushed through the crust in this opening. And all of this movement, this convection current that happens in the mantle, is happening because of differences in density. And so we're going to review what we were talking about yesterday and how this works. And you'll see a lot of differences between that lava lamp and what's happening under the surface of the earth. Okay, so just like in the lava lamp where we see this cycle where you have this continuous cycle of rising, expanding, and then sinking again and condensing, and then eventually warming up again, and it continues and continues. This is happening in that liquid layer under the surface of the earth. So first, what's going to happen is the magma is going to get hot, and it gets hot because down at the core of the earth, it's hotter. And so it's going to actually, if it's not already really liquidy, it's going to get really liquidy when it's down there. And as a result, when something heats up, it adds energy to the particles and causes it to expand. And when it expands and those particles are further apart, they become less dense. So something that is less dense than everything else around it is going to start to rise to the top. So the magma is going to rise. And as it moves away from the core, it also is getting further and further away from that really intense heat source. So as it rises and moves away from the heat source, it's going to start to cool down. As that magma cools, that is going to cause the particles in the magma to move closer together, or in other words, become more dense, or another word for that is that they contract. When something contracts, that makes it more dense because the particles are closer together and there's less space in between them. And something that is more dense than everything around it will sink. And so the magma is going to sink, and this process then starts all over again. So this cycle is going to continue and continue. Now, as this goes along, a reminder, this is like a lava lamp. But as this process is going along, if that rising magma has an opportunity to escape, sometimes it will. So we have this magma chamber underground, and this is where the magma is stored until it's forced toward the surface. And as it gets forced up through the surface, it's going to travel through the vent, which is the tube that connects the magma chamber and the crater. So the magma is going to rise up through there if it is allowed to, basically, and if there's enough pressure built up inside. And if it makes it all the way up there to the crater, which is the opening that erupts ash, lava, and gas, then that's when you're going to have an eruption of some kind. Now, pyroclastic flow is when we have ash, lava, and debris that rush down the side of the volcano. And this is always really key in the kind of damage that might be done or a change to the landscape in the volcano, because this, of course, when you have this like molten material flowing down the landscape, it's going to have an impact on the life and the terrain and any structures, human-made structures that are going to be there. So this is going to be what causes a lot of the impact, as you saw in the video. So you have this diagram in your notes, and it is already labeled for you. What I'd like you to do now is I'm going to ask you to use some colored pencils to add some color. Now, this color is just to give you some inspiration. This picture, you don't necessarily have to do these exact colors. You're also going to notice that there are some labels on this one, that there's a few more labels on this colorful diagram, and you don't need to add those, and you don't need to change labels. Sometimes there's more than one name for things, so don't worry about changing labels. Just leave the labels that you've got, but go ahead and add some color to enhance your diagram. And you probably want to pause it for a minute while you do that. So the location of volcanoes is no random accident. You've probably heard of the Ring of Fire before. Or if you haven't, I'll tell you about it now. The Ring of Fire is kind of this area of the most common area for earthquakes and volcanoes in the world, and that's because they land along a plate boundary. Now, we're going to be learning more about plate tectonics as we go on, and as we get into the next unit after this, we'll go into more detail. So for right now, let's just leave the short story, and that's that we have these tectonic plates or plate in the crust, and that they're in motion. And some of them move towards each other and some of them move away from each other. And what you end up with is basically this big break in the earth where the action all happens. So this is where you're going to see a lot of earthquakes. This is where you're going to see a lot of volcanoes. And you'll see that our most common volcanoes are there, and that's where you're going to have the most action happening. And this is the most common place we're going to find volcanoes. So some examples of volcanoes that fall into this category: Mount St. Helens in Washington, which some of you will be watching a video about later on, or Iceland, which actually, yes, Iceland's a country. It's an island, and it's also very, very volcanically active. So those are the kind of volcanoes you see there. The other kind of volcanoes that we have are on places called hotspots. Oops, I forgot this was there. So they're showing you a bunch of volcanoes in the Pacific Northwest. And these are just a few of the ones that you will find along the Ring of Fire. So hotspots are places other than plate boundaries where magma has pushed through the crust to form volcanoes. And this is way less common. However, some of them have been very, very active and actually have formed a lot of things on Earth. For instance, you can see that Hawaii here is a hotspot, and Hawaii has actually been formed entirely by volcanic activity over this hotspot. So Hawaii, Yellowstone is one of these, the supervolcano that is called the Yellowstone supervolcano, which is under pretty much the entire, I'm going to skip ahead there too. They're over like the entire Western United States is really part of this. That's a big hot spot, which is right, you can see the Yellowstone caldera there up in Wyoming. And that is actually where that main kind of center of it is. So Hawaii, let's talk a little bit about Hawaii. Hawaii is this arc of islands. And there's a lot of active volcanic activity always happening on Hawaii. You'll also notice, though, that these islands are kind of in a pattern, okay? You'll notice that they kind of make this arc. And the reason for that is the movement of the tectonic plates that have happened over this hotspot. We've got this tectonic plate, this portion of the crust that's in motion, and as it moves, a volcano will happen, and it will be enough to form all this new terrain, and then it keeps moving along, the plate that is, And then we'll have another volcanic eruption that forms a whole new volcano. And so you end up with this string of islands um, in the middle of the Pacific Ocean. So imagine the size of that to start initially at the bottom of the ocean and build these islands. All right, at this point, your notes should be entirely filled in for page 11. So take a quick look over and make sure you're not missing any blanks. If you are, back up and figure out what you're missing. But now you're ready for part 3.